Hello and welcome to Chapter 16 Energy, video number 4. By the end of this video, you will be able to explain that the gravitational potential energy of a falling object is converted to kinetic energy. You will also be able to explain that the sum of gravitational potential energy and kinetic energy is the same at all times. Okay, so let us consider a falling ball. Initially, a ball is at rest at a height above the ground, as you can see here. Okay, at rest, yeah. Alright, now because of its height, the ball has gravitational potential energy. Okay, and since it is at rest, it has no kinetic energy. In other words, it's at rest, it's stationary at a height above the ground, so it will have gravitational potential energy, but it has no kinetic energy because it is stationary. Okay, so sometime later, you will release the ball and the ball will fall to the ground, and all of you will know that the ball will get faster and faster and finally hit the ground with a speed v. Okay, so now since it has reached the ground, it has no gravitational potential energy anymore since it has reached the ground now. All the gravitational potential energy that it had is now converted to kinetic energy. Okay, so let us do an example knowing this simple discussion. Okay, I have an object of mass 1 kilogram held stationary 2.0 meters above the ground. Calculate its gravitational potential energy. When it reaches the ground, what will its kinetic energy be? And what will its speed be? Okay, so part A. Okay, we use the formula for gravitational potential energy equals mgh. Sub in the numbers, okay, and make sure you use the SI units for all of them. And then you get the answer of 20 joules. Okay, so since you have the gravitational potential energy of the object stationary 2.0 meters above the ground, so its potential energy or gravitational potential energy, okay, let's write cancel this. Okay, let's write gravitational potential energy. Okay, it's 20 joules, and since it is stationary, okay, because it is stationary, okay, its kinetic energy is 0 joules. And so the total energy, which is the gravitational potential energy plus kinetic energy, okay, is equals to 20 joules. Okay, so now just as it reaches the ground, we know that its gravitational potential energy is 0 joules because it has hit the ground. And we know that the total energy doesn't change because energy is conserved. So that means that the kinetic energy must be 20 joules. Okay, so the answer for part B is 20 joules. Okay, so let's write down the answer. The kinetic energy is 20 joules. Okay, so now the third part then asks us what will its speed be. Okay, so let's look at the answer. So now we know that the formula for kinetic energy is half mv squared, and we substitute the mass inside, okay, which gives us half times 1 kilogram times v squared equals 20 joules, which we have found the kinetic energy. So we simplify, that gives us half v squared equals 20, or v squared equals to 40. So bring the 2 over to the 20, multiply in, and that gives 40. Now you just take the square root of 40, and then that gives you 6.32 meter per second. Okay, so in case some of you are not familiar, how do we write? Square root is the power of 0.5, or let us just write square root of v equals square root of 40 equals 6.32 meter per second. Alright? Okay. So now, just now in the part of video, okay, I mentioned that the sum of gravitational potential energy plus kinetic energy equals total energy, right? And because of the conservation energy, no energy is lost or destroyed. That means that the sum of gravitational potential energy is the same at all times. Okay, so that assumes that no energy is lost, perhaps due to friction or sound or whatever, right? Okay, so in problem like this, we can apply the conservation energy. Okay, energy cannot be created or destroyed. It can only be converted from one form to another. So in this type of problem, we express it in terms of this statement, which says that the sum of gravitational potential energy plus kinetic energy is the same at all times. Okay, So now, let us look at example 6. Now, I have the same object, a mass 1 kilogram, held stationary 2.0 meters above the ground, is then released. Okay, so as before, okay, we have stationary 2.0 meters above the ground. The P is 20 joules. The kinetic energy is 0 joules because it's stationary, so the total energy is 20 joules. Now, when it reaches 0.8 meters above the ground, we are able to calculate its new potential energy. So these are the numbers that substitute into the formula mgh. So maybe let me write this, mgh. And remember, we are still using the SI units. So that gives me 8 joules. Now, because the total energy remains the same due to the conservation of energy, that means that 20 joules minus 8 joules, that gives me the kinetic energy of 12 joules at this level of 0.8 meters above the ground. Okay, so now that answers the question about the kinetic energy. Okay, so the kinetic energy when an object is 0.8 meters above the ground is 12 joules. So let's write down the answer, 12 joules. And so the next part asks you, what is its speed at this level? Okay, so now we have established that the kinetic energy is 12 joules. So the same calculation applies. Half mv squared, sub in the value of 1 kilogram. Okay, for the mass, okay, that gives you 12 joules. So half v squared equals 12 or v squared equals 24. So just take the square root of 24. Okay, that gives you 4.90 meters per second. Right, so that means that, okay, maybe I just write it again using the square root symbol. V is the square root of 24. That gives me 4.90 meters per second. Okay, so summary. So we have explained that the gravitational potential of a falling object is converted to kinetic energy, and we have used the fact that the sum of gravitational potential energy plus kinetic energy is the same at all times. Okay, and this is the end of video 4.